Hello guys, this is CodeNCode and this is video editorial for the problem unique path second taken from Leetcode. The problem is very much similar to the previous problem that we have solved, which was unique path. And the problem was we were given a grid of size m cross n, and in which we have starting point which is 1 1, and we have terminating point which is n cross m cross n, and we have to find the total number of unique paths from starting point to terminating point. The only operation allowed was to go either down or right. So the total number of operations were to count. Now in this problem we are also provided the grid, and in the grid it is also provided that each cell may be empty or it can contain certain obstacle. So an obstacle is represented by 1 and an empty cell is represented by 0. So we have to count the total number of unique path starting from starting point to terminating point. So suppose this is the example problem. Here is the input array. So as you can see, we have to start from this point and we have to go to this point, and there are 3 obstacles in these 3 cells. Now we have to count the total number of unique paths starting from starting point to terminating point. Now the pre-processing part, as you remember from the previous problem, pre-processing part was to fill the last row and last column. Similar in this problem too, the pre-processing part is almost the similar. There are certain changes and we'll see what are those changes. Now first of all, we'll start from filling the n cross mth cell. I'll be considering there are n number of rows and m number of columns, not the other one which is provided in the which is said in the problem statement. I'll be considering n as the rows and m as the columns. So first of all, we will be filling the terminating point, that is cell n cross m. If in the input array this cell is 0, then of course we'll be filling 1, otherwise 0. So since the terminating cell doesn't contain any obstacle, so there's one way to reach the terminating point starting from terminating point. Now what the DP array represents, each cell of DP array represents the total number of unique paths starting from that cell to the terminating point. So DP of nm represents the total number of unique paths starting from terminating point to terminating point. So that is why it is only 1. Now after we have filled the last cell of the DP array, now we'll be filling the rows and columns. So let's start filling from the rows. So first of all, we'll be filling this last row starting from right to left. So I'll be filling this first. So first, to fill the DP array in this cell, first of all we will be saying in the input array whether this cell contains an obstacle or not. If this cell contains an obstacle, there is no way you can reach terminating point starting from this point, so there will be no path. So we see that in the input array this cell doesn't contain any obstacle, so there is one way you can reach from this to terminating point, and that is why we will be filling 1 here, because starting from this cell there is one way to reach terminating point, and that is from here go to here. Now we'll be filling this cell, but this cell as we can see in the input contains an obstacle, so there is no way you can start from this point. If you can't start from this point, there is no way you can reach terminating point, and hence the total number of unique paths starting from this cell is 0. So we'll be filling 0. Now for the last cell, since this cell doesn't contain any obstacle, so we are good with that. But the second thing is you have to see whether the next element in this row is actually 0 or 1. If that is 0, that means there is no path from this cell to terminating point. If there is no path from this cell to terminating point, there will be no path from this cell to terminating point, because there will be the only path that is from this cell to terminating point goes through this cell. If there is no way you can reach terminating point from this cell, there is no way you can reach terminating point from this cell as well. So while filling each cell, we have to check 2 conditions. First, that cell should not contain any obstacle. As we can see, this cell doesn't contain any obstacle. Second thing, the next cell should be able to reach the terminating point, but since the next cell have 0 number of ways to reach terminating point, that is why this cell will also be having 0 number of ways to reach terminating point. That is why this will be filled with 0, because of course if you start from this cell, there's no way you can reach the terminating point, because only operations are allowed are go down or go right. There's no way you can go down because there are no cells to go down. You can only go right, but on the right you have obstacles, so there is no way you can reach the terminating point. That is why the total number of ways you can reach terminating point starting from this cell is 0. So now we have filled the last row, let's fill the last column. So we have to fill this. Now of course we will start from here. So first of all, as again, we have to check two conditions. First, whether this cell contains any obstacle or not. So since this cell contains no obstacle, so we are good with that condition. Now second condition is that the next cell should be 1. That means there should be a path from that cell to terminating point. And since the next cell contains 1, so we are good with that. So starting from this point, you can reach terminating point. So that is why we'll be filling 1 here. Similarly for this, we'll see whether this cell contains any obstacle or not. No obstacle. And can we reach terminating point from the next cell? So the next cell must contain 1. So the next cell contains 1, so this cell can be filled with 1. Similarly for this cell contains no obstacle, and the next cell also, from next cell you can reach the terminating point. So that is why from here you can also reach the terminating point. And now since we have filled the last row and the last column, now we will do the exact same thing that we did in the unique path problem. We will be filling the DP array row by row starting from the n-1th row, and each row we will be filling starting from right to left. So first of all, I'll be filling this cell. The total number of ways you can reach terminating point starting from this cell would be the sum of this plus this. But first you need to check whether this cell contains any obstacle or not. If this cell contains any obstacle, the result dp of ij would be 0, otherwise it would be sum of these two cells. So if I show you the code, here's the code. N represents the number of rows, M represents the number of columns. Now this array actually works on 0 base index system, and I'm going to work on 1 base index system, so keep that in mind. Now I've declared a DP array of size n+1, m+1, because I'm going to work on 1 base index system. And also this is defined as LLI, which I have defined to be long int, because I believe that the result may go outside the range of 32-bit integer. That is why I'm working with 64-bit integer. Now DP of nm, which is the last cell. If you remember, first we have to fill the last cell. So here it is, I guess. We have to fill the last cell. First of all, we will be filling the last cell, and if in the input last cell is 0, then here it would have 1. If in the input the last cell is 1, then here we would be filling 0. That is opposite of what input contains. So the DP of nm would be XOR with 1 of the input. So if the input contains 1 at the last cell, it would become 0. If the input contains 0, it would become 1. And yeah, since the array is actually 0 base index system, and the DP array I'm working with 1 base index system. So whenever I am referring nth row, I'll be in the input, I'll be referring to n-1th row. If I am referring to mth column in my DP array, I'll be referring to m-1th column in the input array. Okay, so now we are filling the last row. To fill the last row, of course, as explained in the slides, there are two conditions you need to check. First, the cell should not contain 1. If it contains 1, that means it contains obstacle. If it contains obstacle, we will be filling that cell with 0. The second condition is that the next element, if the next element is 0, of course it is going to be filled, the current cell is also going to be filled with 0. Otherwise, if none of the condition is true, these two, then the current cell is going to be filled with 1. Same goes with a column. We have to check whether the current cell contains obstacle or not. If it contains obstacle, the result DP of im, that is the current cell, will be filled in the DP array, will be filled with 0. And if that is not the case, we'll be checking the second condition, and the second condition says check for the cell which is directly below you. So to fill this cell, I'll be checking two conditions. First, there should not be any obstacle, and the second, the next cell should have non-zero value or 1 value. If the next cell is having 0 value, that means the current cell will also have the 0 value. otherwise it would have one value. So now that we have filled the rows and the column, the last thing is to fill the remaining dp array, start row by row. So I'll be starting from n-1th row till the first row, and column wise I'll be filling from right to left. That is why I'll be starting from m-1th column till the first column. So I'm filling row by row, and each row I'm filling from right to left. If the current cell in the input, since suppose I'm going to fill this cell, so in the input if this cell contains any obstacle, then I have to directly fill it with 0, otherwise it is sum of the two cells which is below and right to it. And the total number of ways, since we want to know the total number of unique paths starting from cell 11, and that is saved in dp of 11, because dp of ij represents the total number of unique path from cell ij to the terminating point. So dp of 11 represents the total number of unique path from cell 11 to terminating point. That is why we are returning dp of 11. So this is how you solve this problem. If you have any doubt or query, of course you can ask in the comment section. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.